Hello, we're going to be doing now Alkene nomenclature. So I'm going to give you a few exercises, some problems about that. So let's get a structure drawn. And here's what I have here in my handout. The following. Here's the drawing. That drawing, okay? So we need to name that alkene. So first, we want to remember, what is the strategy that we use when we're naming compounds? So first, we want to identify what is the parent chain. And here we want to choose the longest chain that contains the functional group. In our case, is the alkene. So it is in that example that we have here. Next, we need to identify and name substituents, right? Then we're going to number the chain. After we do that, we are going to list alphabetically. And if there is a stereochemistry, we need to specify whether we have E or Z in alkene. If we have chiral centers, we need to specify whether we have R or S. So we need to have all those elements. So going by steps, here, what we have in this alkene. So the parent chain needs to be the longest that contains the double bond. So I'm going to go 1, 2, 3, 4, 5, 6. That appears to be the longest. And if I choose that chain, so let's number that. 1, 2, 3, 4, 5, and 6. All right, so that's the longest chain that contains the double bond. And now that's my parent. So I'm going to name that. Hex is my prefix. And so hexene, right? But I need to say where the double bond starts. So this is 2-hexene. The double bond starts in carbon 2. Now I'm going to go and identify these substituents to the main chain. And I see here one metal and one metal group. So here I am. And now I need to say where they are. Since we have two metals, we're going to say dimetal. But we need to say where those metal groups are. So next step is now I need to say where my substituents are. And they are in 4 and in carbon 5. So this is going to be 4, 5, dimethyl 2-hexene. Now, I need to see if there is, we have listed, and now, is there any stereochemistry? Well, now I see that I need to specify if the alkene here is E or Z. So what we're going to do then is assign priorities. Here we need to remember that I have a hydrogen here, and I also have a hydrogen here. And to do that assignation, we need to use the Kang-Ingold-Prelog rules. We need to assign priorities by looking at the atoms that are here in substituents in those carbons. So saying this vinylic carbon, we have here a CH3 and here a hydrogen. Carbon has higher priority over hydrogen, so I'm going to say that's higher priority. Let's look at the other vinyl carbon, the one and the double bond. So here, attached to carbon, here is attached to hydrogen. So again, higher priority is the carbon. So we see that we have the two highest priority substituents to the double bond on the same side. So this is going to be a Z, the configuration. So that completes the name for that compound. We're going to do one more here, and let's erase that. Keeping in mind that it's the same set of rules. And let's do something else. I'm going to do several problems, but in this video, I'm just doing this too, keeping it short. So let's see. Have another structure. Let's see. My double bond here. And now I am going to have, now, okay. Now here again, we need to see, what is my functional group? The alkene. All right, so I need to choose the longest chain that contains that functional group. So, and it is the chain, but I need to pay attention then how I number that. So the longest chain is 1, 2, 3, 4, and 5. That is the correct numbering because if I check out, if I do the numbering this way, it is 2-pentene. And if I start the other way around, it will be number 1, 2, 3. So that doesn't work. So that's the correct numbering. So now I can write what is the parent chain name. In this 5 carbons, it is 2. 5 carbon, the prefix is a pent, so 2-pentene. We can also say pent, 2-ene to that. Now, once I have done that, let's see if we have substituents to the parent chain. So here I have a chloro, and here I have a metal. And now that we have that, when we're listing, we need to pay attention that the listing is alphabetic. So chloro goes before metal. So when I give the name, I'm going to say 2-chloro, it is attached to carbon 2, 2-chloro, and then I put a dash 3-methyl, dash 2-pentene, running short of space. Okay, now, are there elements of stereochemistry? Let's specify that. And now we have a chlorine, so let's assign priorities to the groups. Again, looking at the vinylic carbon, 1 carbon here. And so what are the substituents at that carbon? We see here that's a metal, so that directly attached is a carbon, and here is a chlorine. In Canning-Gold-Prelog's rule for with atomic number, chlorine has higher atomic number than the carbon in the metal group. So higher priority is chlorine over the H. Here you have to say break the tie, because initially at the other vinylic carbon, let's draw a circle this time. I have a carbon here and a carbon here. So it seems like we have a tie, but they're not identical. So carbon here, this carbon that we're looking at, since we're breaking the tie, is attached to this carbon into 2 H's. The carbon here is attached to, that's a metal, so it is attached to 3 hydrogens. Okay, so again, let's say it again. Looking at the vinylic carbon and what is attached to it, I have carbon and carbon. So same atomic number, so we need to break the tie. It's obvious that the chains are different, but how do we assign priorities? We need to see what's connected to each of the carbon. The carbon on the top is a CH3, so it's connected to hydrogen, hydrogen, hydrogen. The carbon in the bottom here, carbon 4, is attached to carbon 5, but also has 2 hydrogens. Now, to break the tie, I need to compare, and I see that here, carbon has a higher priority over the hydrogen. So overall, this chain down here has higher priority, so the ethyl group over to the metal. Once I have done that, I know that same priority, lowest to the same side, so that is a Z isomer. So I can complete that name by saying that this is Z. And you can say C2-chloro, 3-methyl 2-pentene, or using pent 2-ene. We're going to do more problems about that.